Hello, and welcome to the Chip Observer, the podcast where we look beyond the buzzwords and try to navigate the ins and outs of the semiconductor industry and explore how technology is evolving and transforming our daily lives. As always, we're presented by TechInsights, the definitive source for semiconductor analysis, with continued focus on growth and providing value to the industry. And to get the most out of this podcast, we suggest you subscribe and follow to get the latest news and updates. With this episode, we're doing a quick follow-up to our pre-Mobile World Congress event episode from early March, where some of our top-tier RF analysts were present at the event, and we were able to pick their brains to get a general feel for the affair. So, let us walk you through some of the key takeaways and insights gathered, particularly at the intersection of artificial intelligence, RF components, and mobile innovation. From what we've been able to gather, there seems to be a healthy level of skepticism surrounding the influence of AI on RF. In fact, we should reverse our perception of AI's influence. Most of our RF analysts believe rather than asking how AI will shape RF, we should be asking how RF and mobile architecture are shaping the use and implementation of AI. For example, spectrum policy, operator licenses, and hardware constraints are the foundations. AI, at least today, functions more as a refined tool, a way to optimize these existing systems. Contrary to popular belief, it is not revolutionizing the RF landscape, it's adapting to it. Now that said, there's still no shortage of excitement, and perhaps over-branding around AI. In many cases, we're seeing existing technologies simply rebranded to ride the AI wave. One example, substrates. Substrates were once called engineered and are now being marketed as smart. And simulation tools long used in RF circuit design are now being touted under the trendy label of digital twins. The core principles haven't changed, essentially Maxwell's equations, the four fundamental laws that describe how electric and magnetic fields are generated and interact with each other still rule. But AI is having some influence, particularly when it comes to handset design. OEMs are under pressure to create space, literally, for the AI engines within devices. That means shrinking RF front ends, optimizing for power consumption, and carving out more room for memory and battery capacity. And leaders like Qualcomm, for example, are looking to deliver 6G with full features from day one, unlike the staggered rollout we experienced with 5G. When we shift our lens toward the network side, there's more promise. Concepts like digital twins and self-optimizing networks become much more meaningful at the infrastructure level. AI's optimization capabilities are better suited to managing and troubleshooting networks than they are to reshaping physical RF hardware. At the device level, though, we are starting to see subtle functional AI enhancements. Take, for instance, smart network switching. It's now possible to seamlessly maintain an IP address while moving between Wi-Fi and 5G. This kind of dynamic switching, once merely a standards-based goal, is now actually being realized through machine learning algorithms. So, what's the reality of AI at the edge? The consensus is that it's still early, still in its infancy. The infrastructure is being built, more efficient modems, smarter chipsets, but truly intelligent AI at the edge remains a work in progress. Most edge AI use cases like advanced image processing or contextual awareness on smartphones are still developing. The consumer ultimately decides what succeeds, and that affects everything from scalability to supply chain investment. And of course, we can't ignore the growing attention on reshoring semiconductor production. AI isn't the primary driver force here, but its demand for efficiency is accelerating the shift in RF architecture, from Phase 8 to future Phase 9 and 10. Systems requiring advanced packaging, low-loss interconnects, and smarter module integration. For consumers, this evolution translates into faster, more reliable wireless connections, whether it's smoother 5G streaming, better connectivity in smart devices, or seamless AR/VR experiences. It also opens the door to new applications like immersive gaming and real-time language translation on mobile devices, all powered by more efficient RF front ends. Another key topic that was big at MWC this year was non-terrestrial networks. Satellite-based connectivity, like Apple's emergency satellite texting, has entered the consumer space as a value-added feature. But making these services profitable is tricky. We've seen providers starting with free features, and the challenge will be convincing users to pay for data services down the road. We also observed growth in machine-to-machine connectivity, where low-bandwidth satellite communication could be a game changer, particularly in agriculture and remote infrastructure. Such technologies like Wi-Fi Halo are promising here, offering low-power, long-range connectivity, operating in sub-gigahertz bands, and can provide up to 30 megabits per second under optimal conditions. While it won't rival cellular for robustness, it's ideal for cost-sensitive, lightly managed IoT deployments. Our analysts are keeping a close eye on one company, Morse Micro, which is pushing these advancements forward by using Wi-Fi 4 relays to expand their Halo's reach. From the general review of available data, it seems to be an elegant way to grow the ecosystem while leveraging existing infrastructure. That said, they're not alone. Amazon's Sidewalk network already piggybacks on Echo devices and Ring cameras to provide wide area coverage. While proprietary, it's proven how effective baked-in infrastructure can be. Still, global availability varies. In China, for example, regulatory constraints limit access to the 6 GHz spectrum, affecting Wi-Fi 6E and Wi-Fi 7 adoption. The rollout of future standards will need to align more closely with regional spectrum policies. So where does all this leave us? AI is not driving RF innovation. Rather, it's being squeezed into the spaces RF allows. But its influence is growing, particularly at the network level, where self-healing and self-optimizing systems could become vital to managing increasingly complex environments like 6G. AI's higher-level functions will live in the network core, not at the handset's front end. We also need to keep in mind the broader economic headwinds. Tariffs, trade regulations, and supply chain fragility all play a role in how fast these innovations can become reality. The mobile ecosystem is global, and any disruption can delay progress. In short, we're seeing exciting developments, but the hype is still ahead of the reality. The groundwork is being laid, and as the infrastructure matures, AI will follow and not lead the evolution of RF and wireless technology. Essentially, giddy steps. We'd like to thank our analysts, Chris Taylor, Wayne Lam, and Radu Trandafir, for sharing their notes and insights on these ever-evolving innovations. Note that the contents discussed here today were for informational purposes only, and don't reflect views or opinions of the institutions or organizations mentioned. As always, to get the most out of this podcast, please subscribe and follow to get the latest news and updates. And for more semiconductor details of the snapshot in the industry, we invite you to visit us online at TechInsights.com and sign up for free to become a guest user. There you'll gain access to our platform with complimentary reports, analysis, specialists, and industry-related news. We'll catch you next time with more observations and insights where every listen brings us closer to the stories that matter. Until then, stay curious, stay connected, and stay insightful.